In this problem, we have a circle, and we've got some information about some segments that are inside the circle, or maybe are tangent to the circle, or cut through the circle, and we've got to find some side lengths here. It says, in the figure below, segments ij and ik are tangent to the circle, centered at O. Given that oj equals 8 and ik equals 8.4, so those are on the figure labeled there, what is OI? So we want to find this segment right here. So it looks at first glance like maybe we don't have enough information to figure this one out. We do have some information that's not apparent in the diagram, though. It says that ij and ik are tangent to the circle. What that means is that if this is the point of tangency, j, then this is a right angle, because a line that drops from the point of tangency to the center of the circle is always perpendicular to that tangent line. In addition, if we were to draw in another radius here, I could know a couple of things about that. One, I know that this is also a 90-degree angle, and I also know that the length here is 8. I know that because it's a radius, and so is this radius OJ over here. So they both have to be the same length. Now I've got 8, 8.4, and this side I can get with the Pythagorean theorem, because this is a right triangle. And this side would be the hypotenuse because it's opposite of the 90-degree angle. So I could just say 8 squared plus 8.4 squared equals c squared. So let me pull out my calculator. 8 squared is 64, and 8.4 squared is 70.56. So we'll add those together. So that's 134.56. And then to solve for c here, we're going to just take the square root of both sides. So I'll do that. And I get c equals 11.6. So this is 11.6. There's one other thing you should notice here, and that is that since these triangles are identical, you've got side angle and side, or side angle here. This side here is going to be 8.4. And this is something that holds for all of these situations where you have a point outside the circle. Actually, let me use a different color here. When you have a point outside the circle and you draw two tangent lines to two different points on the circle, they're always going to be the same length. So this will probably come up in problems in the future, and that's a good one to keep in mind. It can help you with some shortcuts. So that is a little bit of work with some uh, lines that are tangent to a circle.